So today I'm talking about the extensible provider architecture. So the parts here, Terraform Provider Architecture. Version 10 gets its own special little note because it has some implications, and then demos, which is going to be a great time. 1 and 2 and 3 there, probably going to go kind of quick. I'll try to talk slow. Demo is, we're going to roll with it. It will probably work. It'll probably demonstrate what I want it to. Just keep an open mind when I talk about Terraform and extensibility. It's kind of a loaded term. So, I have a clicker. Part 1, Terraform, all right? So looking at HashiCorp's mission, provision, secure, connect, and run any infrastructure for any application. Terraform's goal is to be the provisioning part of that mission. Terraform is a tool for infrastructure as code. Our goal is to write, plan, and create infrastructure as code. I don't have notes. I wanted notes. Oh, okay, we don't have notes. Okay, we're going to figure it out then. All right, so we want to create infrastructure as code. We have a lot of providers. These are just some of a very, very small number of them. Amazon, Azure, GitHub, and we cover all sorts of things like infrastructure as a service, platforms as a service, software as a service, metal, probably some other things too. So it's not just, I think I've heard before people think Terraform is a tool for working with Amazon, and it's much more than that. So, all right, infrastructure as code. So with Terraform, you get a unified view of all of your infrastructure, not just your Amazon. We're talking DNS records, your Heroku applications, and it makes it really easy to compose these into a unified view of everything. So with interpolation, we can define relationships between a DNS entry and an AWS instance, and we allow operators to safely iterate on infrastructure over time. So you can start very small and begin to add things. And with Terraform's workflow, you were able to see changes incrementally and make them safely and verify that that's what you want to do. And with Terraform, you get one workflow, many clouds. We want to abstract working with cloud providers into a unified way of doing it, so you don't have to be intimately aware of each platform web console. You just have a single interface, which is Terraform. So key features, Terraform is open source. Who here has used Terraform, right? Most of you have probably used Terraform. Has anyone contributed code to Terraform? Thank you. That's awesome. And even if it's not code, or if it's like a bug or anything, thank you very much. Like that's awesome. Terraform has a huge community, and we are so grateful for that. So yeah, open source. Terraform uses HCL, which stands for HashiCorp Configuration Language. It's meant to be a human-readable but machine-editable configuration language, so it's easy for operators to use. Terraform uses a dependency graph, and what that means is it reads your configuration and it constructs a structure, understanding what parts of your configuration need to come first and what parts can come later, and what parts are unrelated, so that when you're creating your infrastructure, it can create the unrelated things in parallel, which will spin up the process. So instead of just going sequentially top-down, it understands that it can fan out and create the unrelated things at the same time. We have kind of a two-phase way of doing things, Terraform Plan and Terraform Apply. You can skip straight to Apply if you're feeling lucky. But Terraform Plan helps you iterate slowly and safely. You can add a change to your Terraform configuration and hit Terraform Apply, or Plan, and it'll tell you exactly the changes it's going to make. And that gives operators an opportunity to go slowly, but also catch things, what we call drift. You can actually just run Terraform Plan on your configuration, not even adding anything, just to make sure everything is still that way. And you can find those little security group rules that so-and-so added from the console, and they went around you and didn't use Terraform. So it allows you to detect changes in your infrastructure and go back. I saw you shaking your head. No one does that, right? It allows you to find those things and correct them if need be. And then in Terraform Enterprise, you get collaboration, history, audit trailing. Terraform does have built-in support for collaboration in the form of you get remote state. So instead of having the state on your machine, you can actually share that with your colleagues. But over time and the team size, you need better collaboration features, which is where Enterprise comes in there. Okay, so Terraform over the years. 4.0 is right about when I started there. And so this is a map or graph of resources and providers. You see providers have been slowly on the uptick. On 0.9, we had 65 providers, I think. Resources, on the other hand, are ballooning out of control, in a good way, of course. At 0.9, I think we had over 600 supported resources. And I don't think that includes data sources at all. So this speaks really well to Terraform's extensibility in that it's very easy to add these things. By having Terraform core focus on what it needs to and Terraform providers having a flexible, well-defined architecture there, it's really easy to add on more resources and more providers. So Terraform itself, if you're not familiar, is a single binary written in Go. We chose Go because we really like the language, and it lends itself very well to a tool like this. You can compile Go for several different platforms, Unix platforms, Darwin Linux, BSD platforms, and also Windows platforms. You can compile that from a single source of code, and it'll run on all of those. We use a provider provisioner structure, or architecture. So, okay, sorry, I read that wrong. So it's a plugin architecture. Terraform core is a binary, and it communicates with provisioners or plugins over RPC. So it launches sub-processes and communicates with them. And the important part there is that it's just easy to extend it because, it's easy to add your own plugins there. We are now split into Terraform core and Terraform providers. They are separate there, like physically separate. I'll cover that in 0.10. And Terraform, as I mentioned earlier, has a graph, specifically a directed acyclic graph, which means you can't loop. That would be bad because then Terraform doesn't know where to start. But Terraform will detect that if you accidentally add a loop in there. So, all right, so big picture here. You can think of Terraform as this kind of structure here. We've got core, which is in charge of configuration and state and graph, and it's talking to providers. And providers are conveniently on the outside of there. But to a user, it's all kind of one thing. Core responsibilities are reading configuration. Did you want a picture of that? OK. All right. The slides will be posted later. So core responsibilities, reading configuration, managing the state that you have, reading your configuration and reading the interpolation there, and configuring. I'll show you what interpolation means if you're not familiar. And figuring out the dependencies there by understanding that this resource has to come before this resource. Constructing the graph. It reads and discovers, communicates with plugins, and it offers the plan and apply. So kind of another view here. Terraform talks to its plugins, in this case the providers, and the providers talk to upstream resources, upstream providers. Terraform core itself is concerned with graph type ideas, like what's the difference between the desired state and the current state, applying those changes, and also refreshing our state. Those are the concerns that core has. We'll cover provider concerns in a little bit. I guess we'll just go to a slide that doesn't have that. All right, let's see, and I'm hitting back. That would explain what happened there, sorry. All right, again, this is actually kind of a duplicate. Terraform reads the config, makes the DAG. And so what we end up is structures like this. Actually reads top down. So the root is just the core, the very base of what's going on. And in this example, we've got a DNS record that points to an Amazon instance. So Terraform will read the configuration, understand it needs to instantiate the Amazon and DN simple providers, and then at first it needs to create the DNS record in order for the Amazon instance to then use that record. I think I said that right. That's actually backwards maybe, but you get the point. So moving on to provider architectures. So Terraform's goal is to provide infrastructure as code, help you write and manage it. Provider goals then handle the actual provisioning on any infrastructure, service, or cloud. The great thing about this architecture is that core itself doesn't have to worry about these provider level things. Core doesn't understand that with Amazon you have 5 different ways to authenticate and how to manage them. Core just sees that as a block. Core doesn't understand that with an instance you can have several different things, or that there's caveats to destroying instances, you need to disassociate these other things. It just sees it as a block in the graph. Core doesn't care about that stuff. It offloads all of that information to providers. And again, here's some of our provider stuff. So provider responsibilities, detailed knowledge of the specific provider. That's like authentication, endpoints, other various configurations. And providers then define the resources. So a provider will explain, or he'll detail, I have support for all of these resources. Here's where they are. This is their schemas. And the resource itself defines an abstraction around the lifecycle management of this cloud unit thing. Like an Amazon instance, a DNS record, a GitHub team, a GitHub user, a Heroku app. The resources themselves contain that information. All right, so where I said earlier, Terraform Core is concerned with diff, apply, and refresh, Terraform Providers are defined in terms of create, read, update, and delete. If you've ever written a controller in an MVC application, those are all going to be very familiar to you. Terraform, the plugin provider architecture, gives you a thing called helper schema, which helps us define resources in just these terms. We give the provider resource a name, and then we define these methods. And then Core handles the state transitions. So Core will then know that for this resource, I'm creating it, so I'm going to execute the create method. It doesn't actually care what that method is. It just uses RPC to invoke it, and then the providers handle the actual specifics. So providers themselves are actually binaries. You can compile a provider all on its own, and you can execute it. It'll just say, I don't make sense outside of Terraform. But it is its own binary. Terraform Core will automatically discover and grab these binaries. And as I mentioned earlier, we use helper schema to define the life cycles there. What's next? OK, so we're going to look at the folder structure of what a provider looks like. It's at minimum, we recommend about 3 files, right? So you need a main.go because that's how Go does things, and that's how you define it as a binary. Provider.go defines provider specifics, usually authentication and connecting with an SDK. We'll see that in a minute. And then you have your resources or data sources. If you don't know what a data source is, it's like a resource that only has, it's like that, except it only has a read method. And that actually ties into the extensibility of Terraform in that it allows you to access infrastructure that you can't directly manage, either permission-based, like your team does not have permissions to create or destroy, but you can consume this information, or perhaps the provider itself doesn't really lend itself, its API doesn't really let you do that. So a concrete example of a good data source would be, suppose one team is in charge of creating a base AMI using Packer, but you yourself aren't allowed to actually modify it, so you can actually read that with a data source and still inject it into your infrastructure as long as the team that makes it gives you the permissions to do so. All right, so looking at a provider, here we define the structure of what the provider itself needs to set itself up. So in this very simple example, all we need is an access key. We'll just pretend that's an API key. Some providers are a lot more complicated. They allow you to do like a file with configuration and authentication, but they can be as simple as just an access key. And we also define our resources, and not shown would be a data source map, but it's a mapping of this is a resource I support and the name. That's the name that would appear in configuration, and then the method that, or the resource definition that matches to it. So looking at, let me go back, that SC Cloud instance maps to this resource supercloud instance. This is what that would look like. This is an actual definition of a resource. We use the helper schema, and we just return a resource with these defined methods. The methods aren't obviously shown, but that's all a resource is there. You define the read, how to read it, how to create it, how to update it, and how to delete it. And optionally, you don't even have to have an update. If all the attributes defined, I don't show the schema. If all the attributes defined are what's called force new, which means changing them would force a recreation of the resource, then you don't even need an update. Just every change will just hit the delete and then create. Here's an example of what I mentioned earlier as a data source. So I just define the read, and there's an example of defining the schema where you say it has an ID, it has a name, all that stuff. All right, and then back to main.go, where we demonstrate just creating the binary. This is really simple here. The Terraform plugin package there just gives you tools to hook in. So all you have to do is say, I'm calling my provider method, which I can go back and show. That's the provider method right there that returns the structure that says I need a access key. And that's the provider function that that runs it. And so when Terraform can discover this plugin, it just invokes this method, and then the communication, the back-end channel of communicating over RPC is handled all for you. All right, so version 10. In the beginning, Terraform was all one big repository. All of the binaries, all of the plugins were kept in a single repository. And in the initial releases, when you were to download a new version of Terraform, you would get a zip file, and you would unpack it, and you would have a Terraform binary, and then it would have a binary for every provisioner we had. That was how we packaged things at the time. So we had this model, right? We had Terraform, and we had all these things. But they weren't actually inside the Terraform binary. They were just alongside it, and the discovery mechanism would find them there, but you had to copy them all into your path. So as we grew, that presented a big, big problem, because you can see right around version 7, we had 400 resources packed into, I think it was 50 providers. So imagine downloading a binary, or downloading a zip file and unpacking it and having 50 provider binaries in there, 40 of which you might not use yet. So that packaging was kind of hard. With version 7, we re-architected it so that they were still separate binaries, but they were actually compiled into the Terraform binary. The benefit there was that the Terraform binary did not actually expand in the same way that you would think of adding all those sizes together. But it made it really easy for users, because then they just had to download a new version of Terraform. That was great. It had all the binaries in there for it. It was still the plugin system, still had RPC, but it was all in a single binary. And that worked really good, except we ended up with what we would call version sprawl. Starting with version 7, our version numbers started to get really out there. We had I think version 7 had 14 releases. Version 8 probably had a similar number. Version 9, I think, went up to 0, 9, 11. What we found was that as resources were being added, demand for having those new resources was high. Demand for getting fixes and additional features in these resources out was really high. So we ended up releasing about every 2 weeks, because the Amazon provider alone would have 50 plus entries in the changelog just for that provider, because there was so much movement. We were getting tons of new providers, new resources in all of them. So we just had to keep releasing to minimize how much we were actually throwing out there. But as an operator, I would imagine you probably weren't very happy upgrading the core library every 2 weeks to keep up with some of your fixes. So yeah, this is what I was saying. Everything was in a single repository, and they were tightly coupled, right? So we were having releases every 2 weeks. So yeah, version 16.6, 6.16, 7.13, 9.11. So with version 10, we changed that. Graphics. We actually split that. We took all the binaries that were built in, and we put them in their own GitHub repository. We ripped them out and shoved them over there. We changed Terraform so that it'll actually dynamically look for those providers. So when you download version 10 of Terraform, you have no providers. Well, one, the Terraform provider, and maybe a null provider, but basically you have none. And you now have a command called Terraform init, which will go and dynamically pull the providers you need for you. I don't know what my next slide is. OK. So what we've done here is, by splitting them, all these providers now have their own separate release versions and release cadence, which is great, because Terraform core OK. Somebody's talking.
Can you give the talk for you?
Yeah, apparently. It's that entertaining to that guy. All right, so we've separated cores and we've separated providers. Lost all my momentum. OK, so this does a couple things. One, core features take a lot longer to implement. They usually take weeks and weeks to plan, maybe even longer to actually write, because they deal with the core, the graphing, which is the pinnacle of what Terraform has. Providers move a lot faster. Adding a resource or a new provider itself can be done in a period of hours. You know, when Google or Amazon comes out with this new press release of how they added a feature or a new resource, we could have a Terraform resource for that as soon as the SDKs are updated. Like, we have community members and employees who are just on it, trying to get those things in. And so providers need to be able to release separately. So with this split, we've enabled that. Terraform providers can now move at their own pace, be released independently, and Terraform users can now dynamically pull down the providers they need. Per project dependency management, meaning one of your projects can be on a newer version or a different version of a provider than another based on your needs. You could be locked into one for some reason. So you have version locking for those things. Per project. Oh, and so we want to do this to give also like minimum change to operators. Instead of operating Terraform core all the time, you can just upgrade the plugins. You can upgrade them as they're released, or each project can have new ones. Let's see. Nope, that's a bad title. I wanted to skip this slide, but I didn't. All right, so that went kind of fast, but I think we're going to be OK. So talking about extensibility in Terraform, I meant a couple things there. One, Terraform itself is extendable because writing providers and writing resources is really, really simple. It's really, really easy to do once you get the hang of it. I might say that I've been doing it for 3 years. So you don't actually have to know much about core at all. As I showed earlier, all you need to do is tie into the plugin, the Terraform plugin, and the helper schema framework there that gives you the plugin architecture, and you can write a new resource. So what are we going to do here? Demo, provision, secure, connect, run, and infrastructure. OK, so in my demo, I'm going to set up a Heroku app. I'm going to set up a Lambda function, and I'm going to get them to talk. And how I'm going to get them to talk is kind of more interesting than the other two. Again, in extensibility, I mentioned earlier, data sources let you consume providers that you might not necessarily have a lot of direct control on. So some providers just really don't give you the API to do that. I think I'm ready to exit now. I don't know what my next slide is, so we're just going to do that. Oh, yeah, I wanted to talk about this one. So disclaimers. I already wrote the Heroku app ahead of time. I wrote the Lambda function ahead of time. A lot of this was actually already written ahead of time. So I'm not going to do a lot of live coding necessarily, but I am going to touch live code and compile things. The code you are going to see is proof of concept. This is not the quality that I would ship normally, but I wanted to get this demonstration working. And live demos are always kind of crazy. And as Kate mentioned, I have a button. Thanks, Kate. And I've had a very painful experience with the button today because Wi-Fi connectivity has not been so great. So I can't tell you for sure if the button's going to work. All right, on to demos. Can everyone see that OK? All right, so here we go. Nope, that's not what I wanted. What do we have? OK, so Terraform plan. Hold on, I missed something. As demos go. So Terraform plan. This is Terraform version 10. So OK, so plan with just a Heroku file says, I don't know what you want to do because you haven't ran Terraform init. So Terraform init is a command that you will run often. It's safe to do so, and you need to start your project with it. So Terraform init, it will look at my configuration file, which right now is just this Heroku app here. The provider is empty. Most of the providers are going to be empty because, excuse me, they're configured to pull the authentication information from my environment. So that's where I've kept those so I don't show them on screen. And we've defined just a very simple Heroku app. The Heroku provider does not have a means of uploading the code. So Terraform apply. So this is just kind of basic setup stuff right now. Terraform show. Show. All right. So I created an app, but there's nothing there. I can do Heroku open. And oh yeah. OK, so here's the Here's the actual repository. So git remote set URL. Oh, I guess it's the same as when I did it earlier. I've done this demo a couple times right now. So git push Heroku master. I'm going to shove up the code. It's a very, very simple Go application. You're not going to be impressed. Apparently, I haven't set a field. All right, Heroku open. Nothing to see here. Excellent. All right, so we did that. So the next thing I'm going to do is set up a Lambda function, right? So Lambda. Okay. All right, so this is my Lambda function, or the Terraform definition of it. So right here, this is the important part. The name is index. Its file name is index.zip. It's a Node.js application, and it's already zipped up for us. Environment variables, and then this stuff is roles. They're just part of Lambda. So again, Terraform plan is going to fail because it says I don't have Amazon. So I've changed my providers, or I've added a new one. So I need to do Terraform init again. And it discovers that I need the Amazon provider. Now, a quick little detour. Providers, as I mentioned earlier, they're scoped by version. I'm not specifying a version, so it's grabbing the latest ones. And it's kept per project. So they're actually stored in a folder right there called Terraform. So you can see that under plugins, under Darwin, the lock file gets the hash, and then it has the actual binaries in there. We can go and execute those if we wanted to, but we're not going to do that now. OK, so those are the two kind of boring parts of the presentation. Hopefully, those are the boring parts. I mentioned earlier extensibility and working with providers that you can't necessarily create or control completely. I wanted to use some data sources and try to get these two things to talk together. So the next thing I'm going to do is write a provider. And by write, I mean compile it, because I've already written it. This provider is for a streaming service called Twitch. Twitch TV is a service where you can go and stream your laptop, whether you're giving a talk or playing video games, probably. And so I wanted to create a provider there, but Twitch API doesn't really let me create a lot there. It's a lot of consuming. So what I'm going to do is I've got a channel set up, and I want to create a provider for it. So here we go. Switching directories really quickly, I'm now in a directory called Terraform Provider Twitch. And I'm looking here at the file structure, and we see our main.go. Everyone see that OK still? OK. So there we go, main.go. Provider function is the twitch.provider. Going here into the directory, we see that provider. So the provider schema there, we define a schema. It needs an API key. By default, it will read it from the environment. And it's got a description. And then I define my map here. So why 2 here? The API for Twitch, the channels require an ID. You can't, last I looked, you can't look up by a channel name. You need an actual internal ID. So the Twitch user data source uses the token I have. And it will, without any other input, it will find my channel for the person that matches the API key. So the plan there, if we go and look here, is to use the interpolation here. So we say data source, Twitch user, me. And I don't give it any attributes because I'm not looking for a specific person. I want you to find the person based on the token. And that's an implementation detail I'll show you in the actual code there. And then the channel, I want to actually use the result of me. I want to use that ID and filter the channels by that ID. This is an example of the interpolation. So when Terraform reads this, it knows it has to do the user, Twitch user first, before it can do the Twitch user channel, because it needs that value. And these are just an example of outputs. Those will just show the output. I'm not going to run that right now, though. So back to this, if we look at user, it's very simple. We just say get user, and when we get it, we just set the ID and the name. It's a data source, so it only has the single method. And then we had channel, which is also not very impressive. Channel ID, display name, URL. We're going to use the URL here. So I go and I read the channel ID that's given to me from Terraform. I get it, and then I set those attributes. So now they're useful data sources. All right, so now because this is a binary, all I have to do is go install. So what that will do is that will compile it, and then that will put those directory, the resulting binary in my, my path, in my go bin. All right, so there's the original Terraform, and now you see one side by side there, which is Terraform Provider Twitch. So now we can actually use Twitch. Okay, so cat. All right, I'll just leave those there for now. So now I've got provider Twitch, Twitch user, Twitch channel, and I've got those outputs. So Terraform init. Not found. Well, spelled it correctly, and then it'll work. All right, so now, okay, so it doesn't pull that in because it's already in the path. But I can do Terraform plan, and it'll read that thing. It actually won't show anything here because, well, oh, I did I not spin up the, oh, I never did the, whoops. I never spun up the Lambda function, my fault. So what normally, when I practiced the demo earlier, was that it wouldn't do anything because data sources themselves are basically idempotent if you don't have them go into something else. So Terraform plan won't show anything because there's nothing to do there. All it is going to do is read. So right now we're uploading a binary, and here we see our outputs for Twitch. So let's do something with that. So instead of this, we want Twitch channel data.twitch. What'd I call it? Me? Mine. So I want to do that. OK, so now what I've done, incrementally, I have a Heroku app. I have a Lambda function. I'm going to send it, I'm going to update its environment variables so they actually know where to go and how to talk to each other. Our Heroku app has nothing to see there. So when I do Terraform plan, we're going to see that I have now taken the Twitch data source, the channel, and I'm using its value and putting that into the Lambda function and the Heroku app. So Terraform apply. So here I've extended Terraform to a kind of adopt a provider that I don't have a lot of control or access to, but is still actually an important part of my infrastructure. Just because I can't create and completely manage it doesn't mean I can't actually use it and integrate my other existing infrastructure with it. So if we go here, it's now going to load that. Super. OK, so this is the part that gets less than super functional. So let's see, Lambda. We're going to test this just to make sure everything works. So this is my Lambda function. You can see my environment variables there, and I'm going to call test. And it's going to work. It worked. Hooray. OK. So what I did there was the Lambda function connects via IRC. It uses the channel name that I gave it in the environment variable that we got from the data source, and then it actually connects and sends a message over the wire. So the next thing I wanted to do was try to cross over a boundary and use one of these cool little IoT buttons. If you don't know what these are, they're a little button from Amazon. You can go and configure to trigger all sorts of things, SNS. Here, I'm going to use this to trigger a Lambda function, in theory. Now, I have to give more caveats here. In order to set this up, you need a certificate, and you need to enter, I think you need to get like the serial number out of it. So I had to do some manual setup. Those are physical things that had to be done. Like I had to actually connect to this on its own wireless and upload a certificate to it. Those are things that Terraform really can't do yet. You know, we're still adding new features. So we want to What did I call it? What did I call it? Yeah. Wait. Yeah, there we go. Okay, so without covering too much about how the button architecture works, you need to set up rules for it. So what I'm doing here is I want to, with IoT, I want to say when a click happens, basically I'm going to subscribe to this SQL statement here, and that's the actual serial number of my button. Don't go stealing my button. My button. And I'm going to tell it that when the click comes through, I want you to trigger this Lambda function. So we do Terraform apply. I was told once that you're not supposed to show things that fail. So you do Terraform apply, and it says, oh, this doesn't work. I don't know what IoT rule is. So of course, we go to our checkout of the Terraform provider, and we add it. So this is a new resource for Terraform. It is the IoT topic rule. I'm going to give it a rule name. The rule arn will be calculated for me. I'll pull that down. I'm going to tell it what Lambda function I want it to talk to and the SQL that it needs to look up. And this is an implementation of a resource. It is really, really simple. In create, I just grab a couple values that from my configuration, send it off, check the error, and then I set the ID. Same with read. I just read it, get some of the values I already expect, and just set the state. Delete, just tell it to delete itself. So let's go install. Now, when that finishes, a custom build of the Amazon provider is going to have support for this, but not this one. Right? So I'm still on Heroku. I'm still on Amazon version 0.1. So what I'm going to do is delete.terraform plugins Darwin Amazon. Bye-bye. We just have the Heroku one. But I'm going to do Terraform init, and you see I still just have the Heroku one. I still just have that one there locally, but because the Amazon one's in my path, it's now going to use that Amazon provider. I'll show you that. Yeah, so now I've got the Amazon one, the custom Amazon one there. So Terraform apply, or no, plan, always plan. And we see, all right, I'm going to add this rule. For your button, I'm now going to trigger a Lambda function. I have 1 minute and 30 seconds for this to work. All right, so Terraform apply, go. Now, the sad truth. I'm going to click this button, and it's not going to work. I'm going to click the button, and it's not going to work because Terraform is at the mercy of the provider APIs it's given. And despite my GitHub issue that I filed, I think, yesterday, you cannot actually invoke Terraform, or you cannot invoke functions like this without manually adding a trigger. So I made a rule that says whenever the button is clicked, I want the action to get forwarded to this Lambda function. But I need to make a matching rule on the other side that says that this function can be triggered by an IoT button. So I click IoT. Sorry, that went really fast. So I'm going to add a trigger, say IoT, custom IoT rule, and we see my rule. That's the one I made just a moment ago. And that's the query I use. So I'm going to say submit. Now, again, the internet has not been the most generous to me. So we're going to try this. It's actually set up to tether through my phone. And we're going to see if this works. Plug, get an IP address. It blinks. It has to reconnect to the the Wi-Fi every time. It's blinking. And it said green. So in theory, I just pushed a button, which should, in theory, send this. And it should happen in the next, like, 10 seconds. It unfortunately takes some time. Hey, it happened twice. I am resisting comments about JavaScript, which by saying that, I'm not. All right. That's my demo. we had a lot cooler plans for the button, but then that whole trigger thing really, really threw me off. And I tried desperately to try to work around that, but it didn't work. So yeah, what did we do? We set up a Heroku app, which I wrote before. We set up a Lambda function, which I wrote before and learned about JavaScript. We wrote an entire new provider for Twitch, and we exposed 2 new data sources. So now you can leverage Twitch. You can pull information out of there. Can't really create things, but you can still integrate with it because it has an API. Terraform can do something with it. And we extended an existing provider. We took a provider that comes off the shelf that's maintained by HashiCorp, and we added things to it, and we didn't have to wait for it to come upstream. We added it ourselves, compiled our own version. You can cross-compile that. You can distribute that yourself, use it to your however you want. Oh, it's counting up. I'm over. That's why it's counting up. OK. Yeah. And yeah, so we extended an existing provider, added a new resource, did it locally, and I clicked a button. And it actually worked. It worked way better than earlier when I demonstrated. I was waiting like 30 seconds and like sweating the whole time. And now I'm done. Yeah, thank you.